Hello everyone, we are Group C. I'm Huang Junxiang, and this is my group member Li Peilun, Cai Peirong, and Chen Weichen. Chen Weichen is our group leader because he likes to talk and always hold our meetings. Our topic of this final project is class MIDI class classifier. This is the table of content that we will introduce detailedly later. Introduction, code, improvement, and difficulty. My part is introduction. I will brief into the function and dataset used for this program. At the beginning, we go through the MIDI dataset. We import pretty MIDI. It contains utility functions, classes for handling MIDI data, so that is in a format which is easy to modify and extract information from. In this project, we use log MIDI dataset. We can call it LMD. So what is log? It is a unit of measure used in the Indian number system, which signifies 100,000. The LMD is a collection of about 176,000 unique MIDI files. Its goal is to facilitate large-scale music information retrieval, both symbolic and audio content based. They have seven different types of LMD: LMD full, LMD match, LMD align, LMD full file name, match score, LMD match metadata, and clean MIDI subset. Here we use LMD match, a subset of 45,000 files from LMD full, which has been matched and aligned to entry in the million song dataset. We found something interesting is that the million song dataset is a collection of 1 million songs annotated with features from the Spotify. Another interesting thing is that the creator of Pretty MIDI and the creator of LMD Match are the same person. The picture below shows that the different tonality of music saved in different folders. Next part, I will introduce some important functions of the code. The code will be taught detailedly by Peilun and Peirong later. First, download, parse, and match MIDI file. It will show the genre and the path of the MIDI file. The picture below shows that there are many different types of genre like jazz, folk, electronic, vocal, and many others. Second is the extract feature from match MIDI file. The output will show the detail of the MIDI each row. First column is tempo, second is resolution, third and fourth is the time signature. You can see the picture below show that the third column refers to the upper number and fourth column refers to the bottom number. Last column is the chord name. Last part is partition dataset and formatting feature. It separates out the chord name from the detail of MIDI. The first array is the remaining detail of MIDI. Second array is the chord name of MIDI, and the third array is the result of encoding from second array because we need the array as the input for model later. This is the demo video. User input a MIDI file, and the file name will be shown in the first window. Press the Analyze button, then it will pop up another window showing the result which predicts the genre of the input file. Lastly, press the Recommend button. A similar genre song will be recommended to the user. Next, we invite Peilun and Peirong to introduce the part of the code.
Hello, I'm Li Peilun, and now I'm going to introduce the algorithm we wrote with Cai Peirong. And in our program, it will have 3 IPython notebook files. The first one is MIDI classifier, and the second one is MIDI classifier model, and the third one is MIDI classifier GUI. And in the first file, it will output an array of features to each files in MIDI dataset, and the features will be the normalized value. And in the second file, it will output the model of our MIDI classifier of genre. And in the third file, it will produce GUI which allow user to input a MIDI file and get the prediction of the file. And a song with similar genre will be recommended to the user. So, in the first file, MIDI classifier, the first function gets genres. We transform the CLS file into data frame, which indicates the genre of each folder in the MIDI dataset. Also, we number the 13 genres into 0 to 12. So, in that function, we get the genre of each folder, and so in this function getMatched MIDI, we will get genre of each MIDI files in the folders. And in the normalized features function, it will be used to normalize the features we get. And in the getFeatures function, we use Pretty MIDI library to get the features of our MIDI files. And the features we choose to analyze are tempo, resolution, and time signature. And in the extract MIDI features function, it will make all features of all files in MIDI datasets into an array. Cause that going through all the files in the MIDI dataset will cost almost 30 minutes to 1 hour. So after executing all the functions above, we use numpy.save to save the array we make.
Okay, I'm Taipei Rong and I will continue with the MIDI classifier model file. So first we will load the array we saved in the previous file, which is MIDI classifier file. Then we randomly permute the whole set of data and split the data into training data, validation data, and testing data, which is 60% for the training data, 20% for the validation data, and 20% for the testing data. So next, we will make the 5 classifier first, then choose the classifier with the best accuracy to be our model. Then after that, use job_lib_dump to store the model so that we don't need to train the model again and again every time we use the model. However, the accuracy of our best classifier is only 75%, which we think it can be improved, so for the part of our presentation, we'll talk about how we think we could improve the accuracy of our model. So for the MIDI classifier GUI, we use these 4 functions to put the input MIDI file into the model we trained beforehand, and then we will get the prediction of the genre of the music. So this is a graphic user interface part. So we basically use PyQt to write all about the user interface. Yeah.
Hello, Professor. Then I'm going to talk about how to improve our model to get a better music genre prediction. Yeah, the 3 factors our model used to analyze the song are tempo, resolution, and time signature. However, this information in MIDI dataset is still not enough for us to get a high accuracy. Hence, we think we have to increase the music information in our dataset. As you can see, this is a sheet music example from my orchestra, NYCU orchestra. We can get more music information from it, like the red one I mark is the music performance style, and the green one I mark is the volume change of music. And then we can use music editor software like Waveform to generate a mini dataset with more information, which will help improve the accuracy our model made. The next part is the difficulties we face during our discussion, and during our making our model and prediction. Around midterm, our group has two plans. The first one is using machine learning to do music information retrieval. However, we find out that writing a machine learning Python code to do that isn't as easy as we think. Hence come to our second plan. We search on the internet and we find a concept called genetic algorithm, which is related to our project. And is one of the is also using the machine learning skills. However, in the first part, we find using human to rate the melody we like to train our model is too tired. So finally, we come to our final plan. First, our final plan is first, we get media information, from the MIDI classified code. And then we use the second code to training our model. And then we can let the user to input a song. And then our GUI will get prediction and give user the recommendation. And we also update our code to the GitHub. And here's our reference on the internet. Thank you for listening, and I really appreciate our teammates and professor and TS for helping us learns a lot during this semester. We really learned a lot about machine learning. And the skills on Python. Thank you very much, Professor and TS.